I run garden seminars for the city of Guelph, which is in Ontario, Canada. And this year we had a very special guest, Hannah Lewis. She wrote the book called Mini Forest Revolutions and is now an expert on that subject. And we had her in for a talk, and I decided to take that talk and turn it into a video. The book is kind of special because she wrote it while she was in France, and at the same time she was working with local communities to actually implement mini forests. So she has a lot of practical experience, and that comes through in her book. The book is also a gold medal winner from Nautilus Books. I'm going to put a link to the book in the description below. If you want to learn a little bit more about the book, I've actually done a book review on my website called gardenmyths.com. So without further ado, here's Hannah.
Mini forests, and then go through some frequently asked questions and some responses to those questions. So planting a mini forest is a way to restore natural native forests even in small spaces. And the pictures on the right here are mini forests. In the upper right, that's a 14-year-old mini forest with a path through the middle of it in Japan. And in the lower right is a 7-year-old mini forest in Indiana in the US. And then on the left, we have a couple pictures of the more traditional types of plantings that we see around us, which is often a spaced out alignment, and often it's a single species of trees. And so the difference between these two approaches is that when we plant a mini forest, rather than planting trees as individuals, we're planting them as members of a biological community where the plants interact with each other and with native insects and birds and mammals and soil microorganisms and with the environment as an integral unit. And all of these interactions among species make the whole system more stable, more productive, and more healthy. And this is really important because healthy ecosystems function in ways that are vital to our well-being and can counteract the harsh effects of climate breakdown. For example, CO2 buildup in the atmosphere. Leaves transfer carbon from the atmosphere to the living tissue of the land. And the more leaves there are, the denser and vaster the ecosystems, the more CO2 is drawn out of the atmosphere. So it's really a dynamic idea here where it's not just about one tree or one forest. It's about creating living systems that are taking all of that carbon dioxide as a gas and then holding it, bringing it into the land and holding it there. So it's proportional to the extent of functional ecosystems. Another big problem that we're facing more and more is heat waves. A mature tree has the cooling power of several air conditioners, and when you have woody areas of cities, you can lower the temperature by more than 10 degrees compared to treeless areas. Flooding and drought is another thing we're seeing more of, and the living porous soils of intact ecosystems absorb flood water, hold on to moisture through droughts, contribute to plant transpiration, which in turn contributes to rain. Intact ecosystems also clean water and air and protect coastal areas against storm surges. And then biodiversity loss. While ecosystems are rich with life and they are made up of the species we're losing. So when we protect those ecosystems and expand them, we can stem the loss of biodiversity as well. And so this here is a picture of the late Professor Akira Miyawaki, who is the Japanese botanist who developed the technique that we use to plant mini forests. And during his 50-year career that spanned the second half of the 20th century, he was extremely active as a researcher, a practitioner, a teacher, a writer, a speaker. And what I learned from reading all of his writing and listening to him being interviewed was that he understood that humans absolutely depend on intact ecosystems. And he also saw how these ecosystems get cleared without much apparent recognition even of what we are losing. So his vision was for remaining wilderness areas to be created, to be protected, and new wilderness areas to be created everywhere possible and with human help. And instead of calling them mini forests, which is a more recent name, he called them environmental protection forests, which speaks to, I think, what his view of one of their main purposes is. So how do we create new wildernesses using the Miyawaki method? Well, this technique rests on a few main variables. For species composition, we're planting native climax forest species, and we're not planting only the tall canopy trees, but we're also planting understory trees and shrubs to make up the layers of a natural forest. We're often starting with degraded soil, and so we need to restore that soil by decompacting it and adding some organic material to recreate a topsoil and start to approximate the loose living soil that you would find in a mature forest. We're also planting densely, 3 plants per square yard typically, or square meter. You guys use the metric system, so I can use meters here. And 3 plants per square meter. And then we're planting, the plants are pretty small. They're, a couple years old and just, couple feet high when we plant them. They don't have a lot of their own leaves. You saw the picture that Robert showed earlier. So they're not creating that much shade, and the soil is totally exposed. So we need to really heavily mulch it to protect that soil while the plants are still young. So that's another important aspect of the technique. I mentioned climax forest species, which are the shade-tolerant trees that grow in toward the end of the process of natural ecological succession. And so this here is a timeline of natural succession that can last 100, 200, or many more years, depending on where on the planet it is, what type of ecosystem, what type of forest. But it starts on the left there with bare ground. And I think most of us have seen those first few years of ecological succession when you see an abandoned lot and you start to see it getting covered with dandelions and clover and little grasses, and maybe you start to get some thistle, and those plants are coming in. They're faster growing plants. They can make a lot of seeds. They take advantage of the space and the sunlight to just really use up that space. So they cover that space, but then over time you start to get taller plants, bigger plants, slower growing, and they're changing the site. Eventually you may get some faster growing pine trees or birch or aspen. And so then you've got some shade there. And that here, we're kind of in the middle here. And then at some point you get a lot of shade there. And so you get some shade tolerant species that then germinate there, and they grow up and they eventually take over the canopy. And then all of those earlier successional species can't grow there anymore because it's too shady and they really need light. And so then you have sort of a self-replicating community that's shade tolerant, that can be there for hundreds or thousands of years in the absence of a major disturbance. So one thing that's interesting, though, is that these different waves of vegetation are changing the site as they're installing themselves there. So they're loosening the soil with their roots. They're adding organic material to the site. They're cooling it with their shade. They're adding moisture and holding moisture in the area. And so that's part of what is attracting new species then, because the conditions are changing, and so different species that are adapted to different kinds of conditions are taking root. So what the Miyawaki method does is it sidesteps that whole process by jumping to the end and planting the climax species directly. But first, we need to do the work of improving the soil that all those earlier successional species would have done. So that's why we go ahead and deep compact the ground, add organic material before planting, and sort of get it to that climax soil stage as well, or closer to it. So here's a quote from Professor Elgene Box, who was a colleague of of Professor Miyawaki, and he said the logic of Miyawaki's method is to create a permanent canopy of climax tree species directly without going through the successional stages. This creates a more humid, shady forest microclimate as quickly as possible. And so what you're doing is you're really creating ideal conditions. You've got the right species mix because they're adapted to that site. You've improved the soil so the roots will not have a hard time establishing, and then those plants are growing well. They've got full sun, and they grow quickly. And as they're growing, they're branching out, and because they're planted so close together, they touch each other. And so then you actually get a canopy in just a few years, but about 3 years or so. And so that is now shading out the weeds, and it's creating a microclimate and holding moisture in the system. So you no longer need to weed or water that site after the first 3 years or so. And that's something that people really like about this method, is that it does become self-sustaining in just a few years. So an important step in the Miyawaki method is to figure out what that climax community is for your planting site. And this can admittedly be kind of a complex process because of how altered our landscapes are. But a good place to start is to situate yourself ecologically with a map like this that shows the ecoregions of your area. And each ecoregion has its own characteristics in terms of climate and the associated plant communities, which are also related to topographical differences. And so if I am not mistaken, I believe that Guelph is down here in the 7E region, or possibly on the border with the 6E region. And so this is a map from the government of Ontario, and so what is explained on this map, and this is me speaking from Minnesota. I don't know this area too well. I was telling Robert I've been to Toronto once, but that was a while ago. But according to the map, this is one of the most biodiverse ecoregions in Canada, and it's diverse. It's a mild climate, and there are topographical differences which I think are contributing to that diversity, river valleys and then higher lands. And so some of the different plant communities that are listed for this region are hardwood forests dominated by sugar maple, American beech, white ash, eastern hemlock, eastern white pine, and then also some forest remnants of the deciduous forest that spans down the eastern part of North America down to the Carolinas, and so has some more southern species like tulip tree, black gum, sycamore, Kentucky coffee tree, pawpaw, oaks, hickories. I don't know if those are sounding familiar to folks to folks on this call who are in Guelph, but I think the point here is that there are different plant communities that are adapted to different types of sites. So that is something that you want to try to figure out when you begin a mini forest project. And I also want to say that if it's true that you guys are able to grow pawpaws there, then I'm just going to tell you that I'm jealous, because in Minnesota it's too cold for that. So that wraps up sort of the technical overview, and now I want to switch gears and talk about the people who are planting mini forests around the world and why they are planting them, what sorts of local challenges they're dealing with that they are trying to address through their mini forest projects. So let's start in Cameroon. Here. Let me just show you this first. This is I just mentioned that for the book, I had the privilege of interviewing people who are leading mini forest projects in 10 countries, including India, Iran, Japan, China, Cameroon, the Netherlands, France, England, the US, and Lebanon. So, when I talked to all those folks, I was really just also scratching the surface of how many projects are out there. But let's start in Cameroon. in southern Cameroon in the city of Buea, where conservationist Limbi Blessing Tata led several projects using the Miyawaki method to rehydrate the land and the streams that local people depend on for water. And Buea in southern Cameroon is in the Congo Basin rainforest, where a lot of forest has been cleared fairly recently through urbanization and conversion to agriculture, and so also in recent years the water table has dropped, and that's a real concern. So Limby learned about the Miyawaki method and realized that that would be a good way to restore the land along the riverbanks, and that could cool and clean the water, reduce evaporation, and improve the soil's ability to absorb and hold rainwater when it falls. So on the left is the mini forest site just after it was planted in March of 2020. And you can see again, sort of, you can see the mulch covering there, and then you can see some tiny little sticks that are showing where those tiny little seedlings were planted. And in the upper right is the local community that planted, and then in the lower right is what that site looked like a year and a half later. So you can see that that's looking a lot nicer and healthier than before. Okay, and now moving to Paris. So here, one of the issues is that the city is very dense and heavily paved, and so that's contributing to the urban heat island effect. And Paris in recent years has experienced serious and dangerous heat waves. So city leaders envision green corridors as part of a larger plan to mitigate heat in the city during those heat waves. And the green corridors are linear spaces that connect woods and parks and facilitate the movement of wildlife. But they're also meant to facilitate human movement through the city, where the idea is to create enough green corridors that nobody is ever more than a 7-minute walk from a cooler public space. And the Miyawaki method fits well into this vision. The first Miyawaki project was planted in 2018 along the margin of the Beltway that encircles the city. And the Beltway is kind of a cool opportunity to create more wildlife habitat, because it's land that's not, it's sort of a buffer zone between the highway and the neighborhoods inside. And it's also connecting different areas of the city. So they have planted, I think after this one, they did two more since on the Beltway. And this project was led by a small organization called Boom Forest. And so they have continued to plant additional mini forests in Paris and elsewhere in France ever since that first one. Okay, moving to the Netherlands. And in the Netherlands, the main concern and the main purpose for the Miyawaki method has been to connect kids with nature. And this is in a country where 3/4 of the population live in a greater metro area. So Dan Bleichrad is here on the right. He planted his first mini forest with a school in 2015 and has since planted with dozens of schools throughout the whole country. And in each case, it's the kids who plant their mini forest and take care of it, while the teachers integrate forest-based lessons into the curriculum. And moving back here to Washington State in the US, the Miyawaki method has been a way for the Yakama people to reconnect with their heritage and to honor ancestral relationships with native plants that are appreciated not only for food, but for medicine and tools as well. And in this picture, you can see camas and wild rose, both of which have important uses in Yakama tradition and were planted alongside the mini forest that they planted in, I think it was 2021. So that was a quick trip around the world, and now I want to go to some frequently asked questions, and I'll just read them off and then I'll go through each of them. So what is the biggest or smallest size a mini forest can be? Why plant at such high density? Can a mini forest be planted as a food forest? How does climate change affect species selection? And how many mini forests are out there in the world? So starting with the first question, what's the biggest or smallest size a mini forest can be? This picture here is from Japan, and this is a 50 square meter circular forest in Northeast Japan. And if you look closely, you can see that there's just beyond the circle where these people are planting, there's a tinier mini forest, and that one is only 12 square meters. And the person who took these pictures told me that he was pleasantly surprised at how well even the smallest of these mini forests were doing. And here's a similar example. This is a 10 square meter mini forest in a Beirut schoolyard. In the Netherlands, people are planting 6-meter squared tiny forests. They're calling them tiny forest gardens in people's backyards. They're planting them. And so that's like one end of the spectrum. And then in the other end of the spectrum of recent projects this is about 1 hectare 1 hectare mini forest. And here this is before they planted. So this is just the footprint. This is in a suburb of London in a big park. And so this is quite big. These are just teeny tiny trucks down there beside the places where they're going to plant. And similarly, this is in Indiana again, and this was a similar size to that one in London, but the difference is that they planted 1 strip of this that became roughly 1 hectare mini forest around the perimeter of a manufacturing facility. But they did it 1 segment per year compared to that one in London where it was all done in 1 shot. So that was really a lot of work for those folks who did that big forest in London all in 1 shot. I'll just some benefits of this big size. Well, some benefits of the smaller size is just practicality. I think it's just simple. It's doable. You can see in this one in Beirut, they were able to, even in this busy schoolyard, they were able to carve out this small space to plant some native species. And so it's not going to be terribly hard to maintain because that's not a big weeding job there. They can water it quickly. So yeah, practicality and just really fitting in some green space where it's really needed, even when there's not a ton of space. So that's the advantage here. And the advantage of these larger ones is that you're able to create more of an interior space. And for one thing about forests that's important is that there is an interior space where sunlight and harsh winds and harsh temperatures from the outside are not able to penetrate easily. And so the plants that are inside that interior space all the species inside that interior space of a big real forest are protected from those external conditions by that microclimate. So that's easier to achieve in these larger ones, which take more time, effort, resources at the beginning, but then are probably going to be easier to sustain themselves over the long term. And I would say, I think kind of a Goldilocks size that people have settled on is 200 to 400 square meters. And this is that one in Paris that I showed you earlier. So this is 400 square meters. It was planted in a day by a team of just a few dozen volunteers. And you can see this is 5 years later, it's already formed a really nice dense canopy where you can just imagine how cool and moister it is inside there compared to those hot areas on either side. So next question, why plant at such high density? I have this diagram on the right here. It's from Japan, but it shows you 60 centimeters between the different plants, and so that's kind of the standard density. But in some cases, Miyawaki's team would plant at even higher densities, and that was typically in coastal areas, and it would help protect the trees against storm winds because they would be kind of protecting each other. And actually, those circular forests in coastal Japan that I showed just a little bit ago, the way that the person there who shared those with me explained it is that it's their idea came from penguins huddling together against cold winds. So, that you're sort of maximizing the interior space compared to the edge, and keeping all of those individuals a little bit better protected from cold winds. So it's a similar idea with the density, is that you're kind of reinforcing them against particularly strong winds in coastal areas. So it can be a higher density than 3 per square meter. But other reasons for the dense planting is to stimulate interactions, both competition towards the sun, but also the stimulating sort of those mycorrhizal connections in the soil with the beneficial fungi that connect the trees to each other as well. And then also to create a canopy quickly, as I was talking about before. So when you can, as soon as you get to that point where the trees are touching each other and they've created a canopy, then the maintenance becomes 0 to none, because the plants are shading out weeds and holding moisture in the soil and in the system. And another thing I think that's just worth mentioning is that when you look at how seeds fall from trees in a forest, they're falling densely and randomly and close together. So in a sense, it sort of simulates a clearing in a forest where those seeds have fallen, and then the clearing opens and then they just shoot up. So next question, frequently asked question: can a mini forest be planted as a food forest? A lot of people are interested in food forests and wondering if there's some way that those two can be combined. And the short answer is no, because they're two different goals. And the goal of a mini forest is really to reestablish the native ecosystem and to create habitat and food for lots and lots of species, where a food forest is mainly focused on food that humans can eat. So it's just different goals. But there's a big however here, because I'm sharing this picture here from a project in St. Paul that this is a schematic. We'll be planting this forest just in the next couple weeks. So it's this green screen on the left here that it will hug the northeast corner of this community garden. And what's cool about this is that actually in the native species, in this native plant community that we're going to be installing here, there actually are hazelnuts, chokecherry, juneberry, and nannyberry, which are all edible. Many of us know what hazelnuts taste like, but we might not be able to identify that plant if we saw it growing. And most of us probably don't have experience tasting chokecherry, juneberry, or nannyberry, much less identifying them. So this is really exciting, because having some native species that are naturally part of the plant community that would be growing there anyway gives community members a really cool way to interact with that forest and to get to know the species, to be able to identify which ones are the edible species, and to see how they flower, see what their fruit looks like, and begin to tell when those fruits are ready to pick. So in that sense, it is a food forest, but much less than maybe one would imagine. You can also see there's an orchard. We're planning to plant a few fruit trees there, like apples, pears, that kind of thing. And so that'll be, though, separate from the mini forest. It'll be just south so that it gets all the sun that it needs. It won't be part of the mini forest, but it'll be just south of it. And so the other, I think, way that planting a mini forest interacts with or complements the goal of growing food in a city is that it creates ecological balance that's going to help those gardens and those orchards do better. So this green screen, what I'm looking forward to seeing is how it will create pollinator habitat that will benefit that community garden and that orchard. It'll create habitat for pest predators that will take care of some of the pests of those edible species there. It'll also be improving the soil, and that'll ripple out into the garden with beneficial microorganisms and life and just soil structure that will be helpful to the garden. And it'll be holding humidity in the space, and it'll be cooling the area. So imagine being a gardener on a really hot day in August and having that mature green screen there will cool the area and make gardening more pleasant. So I think there is a lot of complementarity between green screens and growing food, but not maybe in the way you'd think in terms of actually combining them, but having them adjacent to each other. So second to last question here, how does climate change affect species selection? And so what we're planting is native species. And what Miyawaki said is that we should plant the native species, the species that are suited to the current climate, topography, and soils. Not the past climate and not the future climate, but to the current climate. And so most plants that are native plants that we know from, reference forests of, a few hundred years ago, most of those plants are still within within their historical native range. They're still growing within their historical native range. And so when we look at native plant communities from the past as a reference, that's still going to be a good guide because most of those species are still going to be doing well in that area. And our goal really is to plant a forest that will grow very well today, because the better it grows and matures now, the healthier it is and robust, it will be better to resist extreme weather and to survive into the future. And also we need those ecosystem benefits now. We need the cooling now. We need the habitat now as soon as possible. So we're growing the species that are best for any given site as it is right now, and then it matures and as a healthy ecosystem, it'll be more resistant to those extremes that we're going to be seeing in the future. One other thing about this is that I think even creating more in situ seed stock can help individual species migrate north. So I think just planting these species that are native here, increasing their seed stock will allow animals and wind to carry those seeds north and help them migrate as they need to. So last frequently asked question that I want to share with you is this question: how many mini forests are there in the world? And I definitely do not have a definitive answer to that because they're popping up here, there, and everywhere. But I'm going to just offer a few broad brushstrokes to give you a sense. So we'll start with Professor Miyawaki, who planted in about 3,000 places in the world, mainly in Japan, but in 18 countries around the world. And so 3,000 places over his career. And then there's A Forest in India, who kind of picked up the baton just as Miyawaki's career was coming to a close. A Forest discovered this method and really kind of lit the fire for people all over the world to be learning about this method and trying it out. So A Forest in India has planted since 2011 has planted hundreds of mini forests in India and beyond. In 2015 is when they planted the first mini forest in the Netherlands, and have since planted about 167 in public spaces and several other in private, homes and businesses and things like that. A urban forest in Belgium has been planting forests in Belgium and France since 2016. They've planted over 100 by now. In 2019, SUGI, which is an international organization that's basically raising money to be able to support mini forest projects around the world, has financed 164 in 24 different countries on every continent just since 2019. 2020, Earthwatch in the United Kingdom burst onto the scene and they've already planted around 200, and Pocket Forest in Ireland is not far behind with 100. And I've recently become aware of Network of Nature, and from what I understand, they since 2023, which is just last year, they've already planted 6, and I believe that many more are in the docket for this current year, 2024. So things are moving fast all around, and here I'm only mentioning the organizations that have really planted a lot, but there's a lot of organizations and countries that are, that have maybe fewer, and so just don't forget those also. But this is to kind of give you a picture of these really big numbers. And then in the U.S., where I am, I want to show you this graph because there's something interesting about it, which is it starts at 2009, and then this light blue bar at the far right is 2024. So you can see that there was sort of this steady mini forest planting in the first 10 years, starting in 2029. Most of that was led by Miyawaki or his team in partnership with Japanese manufacturing companies and their overseas facilities in the US. So then you see in 2021, you see this new little surge. And actually, these are all kind of community-led projects that are kind of what I consider sort of a new wave of mini forest projects. And so 2021, that's when that Yakima forest was planted. There were a couple in Berkeley at schools in Berkeley in California. And in Cambridge, Massachusetts, the organization that I was working for before, Bio for Climate, has led a few. So there's this trend here, which is really interesting. I expect it will be growing. And so now that people are planting, now that sort of there's a lot of recognition and it's become a popular method, people are wanting to really be able to verify the claims that are made about the ecological services that mini forests can provide. So as soon as Earthwatch got started, they also began doing research on the forest that they were planting, as did the Netherlands organization, which was working in partnership with Wageningen University, and then Murdoch University in Australia is also doing research as they begin their mini forest planting initiatives. So and the other cool thing is that Earthwatch and Wageningen and possibly Murdoch, but they're working with citizen science as well. So they're working with community members to actually collect the data, which is just another connection for local people to get to know those native species, get to learn new ecological concepts, and understand what role healthy ecosystems can play in a warming world. So the things that this research is monitoring is carbon storage, water infiltration, biodiversity, temperature growth, and survival rates. So this is cool. Water infiltration, 24% faster inside tiny forests compared to outside. And then up to 65% faster in the older tiny forests. And by older, that's still only a 3-year-old tiny forest. So you can imagine that this might be the beginning of a trend where the more mature the mini forest, the greater the water infiltration, which is going to be helpful in storms to mitigate flooding. And then that water will also be held there in that spongy soil. Mean temperature, 6 degrees cooler inside compared to outside the tiny forest. They monitored biodiversity and found that an average of 271 species of plants and animals were counted per forest, with a maximum of 425 species. And this is just interesting because when they planted these, they planted probably only a couple dozen native species. And so you can see the ripple effect, how this has created habitat for many more species. And then again, soil temperature, almost 6 degrees different inside the mini, cooler inside the mini forest compared to outside for the soil temperature. So this is all good news because it's affirming that these tiny ecosystems can help build local resistance to extreme weather. And since they're modular, the more we have, the greater the benefit. So I would just like to end on this next slide. And if I may play a very short trailer for a documentary that will be released this year called Making a Mini Forest. It's a documentary by Angelina Lee, who spent about 6 months in Western Europe interviewing and videotaping the mini forest projects that were going on in Western Europe. So I'm just going to play this. It's only about 2 minutes long.
On se rend compte de ce que les arbres ont d'important, généralement quand on les enlève.
The world has lost about a third of all forest cover, and what remains continues to be degraded and cleared.
Dit stuk bos is nog een van de laatste stukken oude boskern in Nederland.
Forests filter the water we purify the air we breathe, keep CO2 out of the atmosphere, and provide habitat for countless species.
Et je dis, de ce temps-là, faisons une expérimentation.
A new approach to reforestation is capturing the imagination of communities everywhere. Miyawaki Method is a forest planting technique that seeks to restore and support local biodiversity by planting native forests in small areas.
Les seuls terrains qu'on a sont des terrains forts. Donc on est une espèce de non-sens par rapport à notre objectif.
Comme les plantations sont très denses, on peut, même sur des espaces qui sont assez réduits, réinstaller un écosystème.
Kind of a cliche. The best time to plant a tree was yesterday, and the second best time is today. So that is the end of the presentation.
All right. Well, thank you very much. That was great. We have a few questions. So the first one are, do you have any photos? This may be a little hard to do now, but maybe you can describe them, of what the forests look like when they're much older, say in 20 years. How do the trees behave? I mean, this was my first reaction to them. We're going to plant the trees so close together that in 20 years, pretty much all the trunks are going to be touching, right?
Yeah. Well, there are pictures from Japan of those forests that the first one was planted in 1971. So that's about 50 years old now, and they're doing great. So the Miyawaki wrote a book in English that has a picture of those forests on the cover. I could probably also find a picture fairly quickly to show you, and that was something that I definitely should have put in the slide. So apologies for that. But yeah, they do well. They're tall, mature forests now. I think one thing to know, or to sort of like recalibrating your brain to think about planting trees and what the goal is. So normally we're concerned about individual tree survival, which makes a lot of sense. But in the case of the Miyawaki method, we're thinking about the survival and health of the system as a whole. And so the survival rate is really high over the first few years while there's still plenty of space for everybody. And then like 95%. And then after 5-10 years, it drops to about 70%. So there is some natural selection where some individuals are falling away and the other ones are taking up the space. So it does kind of spread itself out in that way. But yeah, so that's kind of the progression over time.
Yeah, but by the time this forest is 50 years old, most of those trees have to be dead because there's just no space for them.
Let me see if I can find a picture.
Yeah.
After the 5-10 years, where it drops to 70%. Yeah, I guess I don't know the numbers at 50 years, and that's also a good question. But I guess what was important to Miyawaki and so what I understand too is just the importance of the forest as a whole, that it's doing well as a system, and it's that density kind of helps it get going at the beginning. And then it finds its own way over time to become a healthy forest that's gonna persist over time.
Okay, no, this is an interesting one. So I'm going to read the whole thing. I have 3 mini forests, but I'm finding that the shrubs planted as the understory are starting to shade the trees. I assume because they're taller than the trees. Is it better to plant the shrubs later in the process? Perhaps early on you just plant more
No.
vegetative plants that are not going to get very tall.
Yeah, no, you plant them all at the same time. One thing is that the way Miyawaki's team planted was a very high proportion of tall trees. So, 70% canopy and understory trees compared to just, 20-30% shrubs. So the shrubs are still taking up a pretty minor spot. The other thing that could be going on is maybe those shrubs are earlier successional shrubs. So, climax species, pioneer species grow really fast. And so that's kind of why I touched on that ecological succession, and the point of planting climax species is because actually Miyawaki didn't include any pioneer species in his plantings because the pioneer trees they grow faster, and then they shade out the climax trees. So then you're not actually getting to that climax stage quickly, which is the intention. So I think in the case of the question that was asked, it might be that those are earlier successional, faster growing shrubs, or maybe there's too high of a proportion of shrubs. But no, you definitely always plant them all at the same time. And if they're all climax trees, they'll be growing at a rate that allows those tall canopy trees to kind of stay ahead.
Interesting. The planting in Guelph, I'm pretty sure, has equal number of trees and shrubs. That planting that I showed at the beginning, it was 500 trees and 500 shrubs, if I remember correctly. So, do you do any pruning of these trees or shrubs, or do you
Nope.
just nature take its place?
Yeah. The whole goal is to get to that kind of 3 or 4 year mark where it's taking care of itself, like any forest takes care of itself and doesn't need to be pruned. There may be some conversations with municipal staff that maybe don't want branches going out over a sidewalk or something like that. So there may be some like compromises in that sense, but from the forest perspective, you just leave it be. Like any forest, it'll take care of itself, and you shouldn't prune or do anything.
Okay. You had mentioned the pawpaws, and Guelph is kind of a unique spot in that they aren't native here, but if you drive an hour south of here, they're native there. So there's this like dividing line.
Interesting.
Which south of us is the Carolinian forest, and they're native there, but right in Guelph, they're not, but they grow quite well here. They're a little hard to establish maybe when they're young, but they do grow well. And the University of Guelph has several larger trees there. So this question, probably not something you're familiar with, but I'm going to ask it anyways. So we have this succession process that's going on from, let's call it, fields to forests. Has anyone ever looked at the ratio of fungal to bacteria in the soil and how that changes in one of these mini forests?
I believe that is something that's probably on the research docket for all these new initiatives. And I would imagine it's increasing because because the fungal connections are so vital to forest species. But as far as research, I can't point to a specific study that's been done. And a lot of this research is just getting going right now.
Yeah. Yeah, that's sort of what I mean. The argument for the fungal bacterial ratio is there are some individuals, and I don't think it's a majority of scientists, who feel that we need to change the ratio to make the plants grow. So if you want to grow trees, you change the ratio so you have a higher fungal ratio so trees grow. I suspect it's the other way around, that as the trees grow, they change the ratio themselves. But
Yeah. I mean, there's probably some back and forth going on, but I do know that some projects are experimenting with trying to inoculate the soil with beneficial fungal species as part of the soil prep process. Not all of them are doing that, and I don't think Miyawaki ever did that, but that is.
Okay. I have one final question. And so I spent a fair amount of time looking at these forests, and a lot of this makes sense. Putting the forests into these urban areas makes sense. You know, the fact that they cool, you get a wider diversity of species, all that sort of makes sense. I mean, you get that anytime we replace, fields and grass with forests. What I have not been able to find is a single study that validates the density of the trees. So, for instance, the density, is like 2-3 feet apart. These trees. Okay, so if we took that same plant, the same trees, the same variation of species, and so on, but we plant them at, say, 1/10 that spacing, would we end up in the same place, and or would we end up actually with healthier trees in the long run? When we're at 50 years, are those trees going to be more normal and healthier because they had more space to grow? One of the things I've noticed, I have a little wooded area, and it's a sugar bush, basically sugar maple. But at one point, all the seedlings came at the same time, so the trees are all the same size. But they were so crowded when I moved in that they were all spindly, had no branches except right at the top, and they were reaching for the sun. So what I did was I came in and thinned a lot of them out, and then they started creating branches lower down, and they became more normal shaped trees, and so on. So I can't help wondering if this close planting is an issue. And so I went looking for some studies that looked at, planting them at 2 feet apart and at 6 feet apart or 10 feet apart to show that the close planting actually has a long-term benefit. Now, the short-term benefit is that close planting does mean less maintenance, and they probably grow faster, which is one of the claims I see a lot, because they're struggling to get light, so they grow tall. But what is the long-term benefit? And I couldn't find a single mini forest where they actually did a control.
Mm-hmm.
And in fact, I talked to the people in Guelph and said, look, why didn't we take this area and split it in half and do dense in one half and not so dense in the other half, and then come back in 20 years and compare the two, right? We're going to come back in 20 years and say, well, we have a forest here, and it's cooler, it's got trees in it, it's got all kinds of animals and birds and so on, and it's done all that. But we don't know if that dense planting was actually beneficial, right? Mm-hmm. So I don't know if you know of such a study, but I couldn't find a single one.
Yeah, actually, I'm remembering one now in India where they did a Miyawaki planting, and then I think they still use native trees, but they spaced them out more. But it wasn't a long-term study. It was it was only five years by that point. And the Miyawaki method was doing great, and I don't remember the specifics, but I believe that it was doing as well or better than the one that was spaced out. But that's only 5 years, so it's still supporting that early benefits thing. While we're talking about this, I'm just going to share the picture I found. Can you see that?
Yes.
So this one, this was planted in the mid 70s, and this is March 2019. So this is a pretty old planting, and this is at Yokohama University, and it's just a narrow strip on either side of this entrance to the university. So there's a picture. But your comment about the shape of the trees, I think also we're used to seeing trees that are growing in the middle of a yard or in the middle of a boulevard that are big and round and stretching out in every direction. And I think that when you are in a forest, they don't have that luxury either. They have that luxury when we plant them in the middle of a yard, but not necessarily in a forest. In the forest, they do tend to be taller with more of the branches up at the top. So it's kind of it's partly that it's a difference between the way trees grow in a forest compared to the way they grow when they're in the middle in a more savanna-like context.
Yeah. Well, it's certainly true in a forest. They don't grow perfect. But what happens in a forest usually is that a few of them win out, and the others either die out or stay as understory trees until light arrives.
Mm-hmm.
It would be hard to find a forest where you have mature tall trees every 2 feet apart.
Mm-hmm. Yeah, no, and I don't know if you can how well you can see this here about the spacing, but they're not super wide trunks, but they're decent, and they're still kind of spaced out there. I would love to go into a mature mini forest at some point, but I have not made it to Japan to do that yet. But yeah, those forests, by all accounts that I hear from people there, are doing well as forests. The trees, some trees don't make it. They fall down, create habitat for other animals, and then eventually degrade and add to the soil. But the forest, I mean, when you think about the forest as a whole, that's kind of the focus of the Miyawaki method, and in on that count, they're doing well.
All right. Well, I don't see any new questions coming in, so let's end it there. Thank you very much for coming. I think these mini forests are really exciting, and if they get people planting more forests, particularly in small areas and urban areas, then that's certainly good for the environment. So I think the planting of them is very important. I'd like to see a study to be convinced that the spacing's right, but
I think it's a great time to be doing those studies right now. I mean, that's what is exciting about the Earthwatch and Murdoch University in Australia, that they're trying to document all of these different aspects of the Miyawaki method.
But unless they planted controls, which would be trees that are spaced farther apart, they're not going to be able to measure that. And that's the issue. For instance, I've read all the reports out of the Netherlands, for instance, and they document what the forest did quite well, but they never had a control to compare it to. Right. So what they basically concluded was that forests add a lot of benefits, but we still don't know what the best way is to create those forests. Right? So
yeah, I would encourage you guys to do a study like that.
Yeah. Well, I tried to talk to the city about that because ours is only a year old, so it would be easy enough to double the space and do that study. I've even talked in Canada. There's a group called the Green Communities Canada, which is promoting these forests across Canada, and I even talked to them and kind of encourage them to do the same thing next time they put in a mini forest in. It's just split it, and so that we have some data in 20 years. Yeah. All right. Well, thank you very much. It was a great time, and really appreciate you coming in.
Yeah, thank you for the invitation. Appreciate being here.
All right. Thank you very much. I hope you've enjoyed this video on mini forests. If you'd like to see more of my videos, have a look at this link here, and it contains all of my videos. Happy gardening.